All right. Again, welcome everyone. Today we're going to be going over Git fundamentals. We are going to start to get Git, but we're not going to actually get it by the end of this lecture. This is just the beginning. All right. In between classes, I'll share a couple of other readings. There's a really good book out there called Git from the Bottom Up that breaks down Git to like it essentially a developer went through the entire process of saying how they never really understood or learned how to utilize this tool named Git. Git is a tool that's specifically used for version control, tracking your files and communicating with GitHub. And as we'll learn today, a lot of developers pretty much get by the majority of their career only knowing a few commands of Git, but never truly understanding how this tool works, how it's tracking individual files, um, not creating copies, but just tracking the differences in between files and then pushing them up to GitHub whenever they're ready to be pushed. And truly understanding the mechanics of what's going on in the background of this tool is what's going to really give you that information to get. All right. Otherwise, you're just going to end up in that same cycle of rinse and repeat where you're just utilizing the same exact commands over and over again. And when you get into a really bad problem where you end up in a headless state or you don't understand what's going on with your Git, you have to run to the Git master of the organization to see if they can give you a hand. All right. Which is okay. But definitely not what we want for you guys coming out of this boot camp. So we want to ensure that we give you all the knowledge that we can regarding this one specific tool. Again, this tool is massive. So today we're going to concentrate in the very top layer and the most basic information regarding Git and GitHub. So I'm going to start off with GitHub actually. So here I have GitHub. On the left side, you can see that I have a directory named learning Git with just one README markdown, but nothing has been initialized. Yesterday we went over how to install Git, and for those that were in Mac OS, I kind of talked a little bit about the difference between Git and GitHub. So let me go ahead and go over that difference one more time. So here we have our local machine, and here we have actual GitHub. Right, both of these things are true, solid events. They're separate from one another, and they can create copies utilizing a tool, but they are not the same. So here I have my machine, and here I have GitHub. So now you can see that in GitHub, we have something like Platoon curriculum, right? If I go to Platoon curriculum, I can see that I have all of these directories. I have the actual curriculum itself, all the topics I'm covering. But I can put this inside of my own machine and be able to interact with it, make changes to it, do the whole shabam bam if I really wanted to, right? Well, how do these two different mechanisms work together? How do they talk to each other? Well, that's where Git comes in. And I'm going to purposely draw Git in this motion here where it's kind of invisible because we're not really going to be able to see Git. So here we can see Git, GitHub. I'm going to make them a little bit smaller. And the way they communicate to each other is actually in a vice versa kind of communication here. And let me turn those into solid. All right, so Git talks to GitHub, or my machine can talk to Git, and Git can talk to GitHub. And the same thing vice versa. Or I can have GitHub talk to Git, and I can have Git speak to my machine to update whatever files that I want it to do. And this is the main communication that we're going to be covering today, is how exactly we can get our machine to utilize this Git tool to talk to GitHub, right? So now this is how the communication flow works. But even though the communication works this way, this isn't the actual structure that we'll see. And this is what I mean by that. I'm actually going to make a copy here. And I'm going to label this the flow of Git. And I'm going to actually label the bottom one the structure of how Git is working. All right, so yesterday again, for those of you that were inside of my room, I talked a little bit about this, but not much. Git is actually a tool that exists within your local machine. It is not something that's like on the web. It doesn't work as it doesn't necessarily work as an API. It's not like you're making request to some sort of third party or anything like that. All right, Git is running kind of like as a background. I don't want to call it a background service. A Git is a tool that exists within your machine, right? Well, if within my machine, I have a directory that holds other directories. Oh, I think that's it. Oh, I have one more. All right. So now I have a directory holding other directories. And let's see if I can make a separate icon for files. Let's go with diamonds for files. Why not? All right. And then I have a couple of files there. Well, I have all of these files. And we know that GitHub is essentially just one massive page on the internet that's running its own internal server to keep track of pretty much everyone's work. Well, how exactly is it that that is going to happen, right? How do I tell GitHub, this is what I want you to keep track of? Well, here's my project. I'm going to move these down a little bit. What I'm going to do is I'm going to tell Git, hey, I want you to initialize yourself within this repository and keep an eyeball on it. I want you to know that this exists. And I want you to know when a file is saved. I want you to know when a file is deleted. I pretty much just want you to know everything regarding my project. All right, if I make a specific line change, you need to be able to tell me where exactly that line change was, when it happened, and if somebody leaves a comment, why it happened. So Git's going to keep track of that depending on my following list of commands, right? And we'll go over those commands here shortly. Git keeps track of my project. I wonder if I have an eyeball here. I don't have an eyeball. It would be cool if I had one. I'm not going to attempt to draw one because I know that I'll fail. So here we have Git. It's keeping an eyeball on my project. And once I'm ready to actually push it up to GitHub, or I've made a significant change or significant progress, I'm going to make something called a commit. Again, just a vocabulary. Don't worry about what exactly it is that means just yet. Once I have that information, I'm just simply going to tell Git to send that to GitHub. But how does that work? Well, Git, the entire time that I'm working on my project, I want to clarify that it's not making copies of my entire project, but it's keeping logs and tracks every time my project has a change, right? Over and over again. It says, hey, this file had a deletion on this line, and this is the text that was changed. And that's for efficiency purposes. You can imagine if you had a project that was thousands upon thousands of files and directories, it making a copy every time something is changed and then trying to send that entire copy up to GitHub would be, it would be terrible. It wouldn't be a very efficient mechanism and it wouldn't work really well. So instead, what Git does is it keeps track of the changes and annotates them in something called blobs. Again, these logs are coming in, they're all being written, and they're kept track. They're happening sequentially. So what I mean by sequentially, and let me take a look here. I'm just gonna call these logs. Oh, that's a terrible square. And so here we have 1 log, we have 2 log, 3 log, 4 log. Oh, there you go. All right. So what I mean by sequentially is that each one of these logs are connected, but they aren't just connected in a way that I can remove one log and remove it from the other. They are all connected in a hard chain kind of viewpoint. And this might have been a lot easier if I just copied and pasted these two. So I'm going to do that. Right, they're connected as a hard chain with one another. They only know about the previous existence of which one exists. So they know that their previous could either be another log that exists somewhere within my log history or null, because if it's the very first one, there's nothing before it. All right, so that's all Git is doing, is just keeping track of all these different logs. And maybe I could point a little arrow there saying that's what Git actually looks like. All right. Well, once all these logs are set and I'm ready to actually make a solid change, I want this to be concrete. Keep it somewhere where it's going to be safe away from my machine. If my machine dies, I drop it, my dog runs me over when I'm trying to walk down the stairs and there goes my laptop, or, my kid spills apple juice all over my laptop and there it's gone. Well, now my project is gone on my machine. But how do I protect that? How do I get it to a place where it's going to be safe? Well, what Git actually does is it communicates to GitHub and it tells it, hey, I have all of these logs. I want you to utilize these logs to make a copy of what this project looks like. So then GitHub receives all of these logs and it literally follows them as if it was a set of directions. Okay, in log 1, this file was created. In log 2, this information was added. In log 3, this information was deleted, and continues going down the line all the way into the latest log. And if I move it over to GitHub, after following those directions or that recipe, will end up with an entire project that mimics what I have in my current machine. All right, so there's the structure, and now we see the flow in reference to the structure. That was a lot of talking. Does anyone have any questions over that information so far?
Yeah, would it be safe to say that Git is a middleman between GitHub and your machine?
Essentially, yes, it works. It works kind of like as a communicator or an interpreter, right? It's yeah, or the middleman. He
Okay.
takes pictures of what's going on and then delivers it over to GitHub. Yep.
Okay. And then just to be clear, when you have Git initialize, it is keeping track of everything. So like if you make the slightest change, it'll keep track of it.
If the file gets saved, yes, it
Okay.
works upon a save basis.
And then you said that the logs are connected sequentially. So so that means like you can actually go back in history. So like if I wanted to go from the final version 4 versions back, that would be fairly simple because of the way that it's structured.
Exactly. And
Okay.
that's the way that it's meant to be designed. It's designed so that I think we were talking about it yesterday, right? Where we're talking about if you're trying to solve a problem or and then you go for a better refactor. And I think we were talking about it in reference to assessments. Let's say that I completely break my assessment. It's done for. Like I made this one line change of code and it completely just broke everything. That's not what I wanted to do. Maybe it changed some of the vital data that I needed for my assessment to work correctly. Well, I can use Git to look at the history of what I have within my logs, choose which one of these logs was still working correctly, and just go back in history to that one log. And
Easy
once I go
peasy.
back to history into that one log, I can choose to make a new log that would overwrite this one. And then these two logs would exist simultaneously to one another, kind of like this.
And this would be called a branch.
Yeah, exactly.
Okay.
All right.
And then finally, so GitHub itself is really just a storage device, like a cloud storage.
Essentially, that's
Okay.
correct.
Okay. I know there's a lot more to it, but like just as a general thing.
No, yeah, no problem at all. In case this is good information for everybody, thank you so much. All right. It doesn't seem like there are any questions regarding this information, so I'm going to go ahead and move on to the next portion here. So now we have our flow, our structure. We kind of understand what's going on here in GitHub, in between my machine and GitHub. And I know Git exists because if I type in Git here, it gives me a series of commands. So it's all right, well, you typed in Git, but you're not really telling me what to do. Just so you know, -v is a flag that you can utilize, and I'll tell you the version that you're currently using. And Git is trying to be as helpful as possible. Please don't let it fool you. Even though it's trying to be helpful, it is not at all a nice or friendly tool. A lot of the names that they have here don't match what it is that you're trying to do, especially as you get into more advanced stuff. But this is still a pretty good little log that you can read through and try to figure out what exactly is going on within each command. But all right, it tells me, hey, this isn't working correctly. You're not telling me what to do. Git is a tool, but it does take an argument. I need an actual command. What about Git is it that you want me to do? Well, like I talked about it before, currently I have my machine, Git, and my structure, and I have my project. But Git has no idea that it's supposed to keep track of this project just yet. And that's because I haven't initialized yet. So I'm going to go ahead and clear my terminal here. I'm going to run git init. Now, if we pay attention to the left side bar here, when I run this command, you're going to see, I believe you're going to see a little change here where my README is going to turn into a green file. All right, there it is. So now I have my green file. And what is it saying? All right, so now we have an initialized empty Git repository in users, Francisco Avila desktop, learning git.get. Well, let's look at this path here. All right, this path here takes me all the way to learning Git, which is what I expected. But now I'm getting this .get. Where did that come from? I never created that directory. Well, Git needs a place to store all of its logs and a place to communicate or identify where the root of the project is located. So when I run that git init command, it says, this is where the root of the project is. So this is where I'm going to start looking at. This is where my file tracking is going to start. So now if I run ls-a here on my terminal, I'm going to see a .git directory. And if I were, again, if this is a directory, so if I were to change it to .git and run ls, we can see the .get has a couple of different things. We have head, info, configurations, different objects, references that we can use, descriptions, and hooks. We're not going to go into the entire folder structure of Git, but this is essentially how it keeps track of these different logs, right? Every time I create a log that falls under an object, and if it's the log that I'm currently located in, it's going to be identified as head, right? So Git is currently initialized where my head is at an empty README. Nothing exists just yet. I just have an empty Git folder with nothing inside of it, inside any of these other directories. All right, so that's about it for initializing Git. Does anyone have any questions about what Git init actually does within a repository? Okay, awesome. Doesn't seem like there are any questions. So now that I have this Git, oh, go ahead.
I'm sorry. So yeah, so when you erase or save your project, you initialize it first and then do the other commands to push it to GitHub, correct?
Exactly. So right now, all I'm
Gotcha.
doing, or the only thing that I emphasized, was actually taking a look at my project. So Git now just is looking at my project, but it doesn't know about any existence or anything that's working there. So now let's take a look at what exactly is going on within Git. All right, there's a couple of commands that Git offers to us to actually see what Git is tracking or Git is getting, right? So I can run Git status. And when I run Git status, Git gives me a little bit of information about what's going on within Git. So Git status is telling me, hey, you're on the main branch, which also a question, where's that coming from? What is a main branch? You don't currently have any commits yet. And then it's telling me that I have untracked files. And then it even tells me the command that I should utilize to add this file. All right, so here I see git add, and then these these arrow brackets are telling me this is an argument. You have to specify the file that you want to add to Git to include in what will be committed. Okay, well, what is it that's going to be committed? What does that mean? All right, nothing added to commit, but untracked files present. So it's telling me you currently don't have a commit. So here I see that you currently don't have a commit. It tells me you have untracked files that exist. This is how you add them to Git if you want to. And then in red, it says, this is the untracked file that I don't know exists. And then finally, it tells me if you want to make a commit, you can, but you should be aware that they are untracked files that are currently not being tracked by Git. Well, let's break down this little structure here a little bit more. I apologize, everyone. I hope that works well. All right, and here we're going to talk about Git to project structure. All right, so when I ran Git init, Git knows about all of my project name. But within my Git, not only does it know about my project, there you go, but it's attempting to keep track of some logs. Well, how are these logs created, right? What exactly is happening here? Well, there's two separate stages. We have our, oh man, we have our, and I believe this is called, I may need a little bit of help here, Adam. When you add something, it gets placed where again? I forgot the name of that delegation.
Oh man, staging.
There you go, staging. Cool.
Yeah, staging. I always forget this. Yeah, the 3 trees.
Yeah. All right. So now it falls within the staging area. And once it's within the staging area, it then waits to be committed. All right. So Git is already magical as it is. I can't really see exactly what's going on. And as you'll realize, even though I have access to this .git directory, it becomes pretty unreadable really quick because of the way it's structured. All right, everything's really well isolated, and it's done like that on purpose. Well, what exactly is it that I'm telling my project to do? So it keeps track of all this information, or it's keeping an eye on my project, but it doesn't know how to handle the information within my project. So how can I tell it how to handle this information? Well, this is where the next series of commands come in. Oh, that's the wrong thing. Where's my sticker? I think that's my sticker. There you go. All right. So we have commands such as git add, which we know can take a file extension. And then we have commands such as git commit. All right. So what does git add and git commit actually do? Oh, I see what that's doing now. Can't make it smaller. All right. So what is it that git add and git commit actually do? When I say git add a file, what it actually does is it says, all right, well, this file may or may not be committed. So what I'm going to do is I'm going to place it in a safe place And actually, I'm gonna make this a little bit more obvious. I'm going to put it in a safe place and keep track of it. So when I run git add file1, it puts it within the staging area, but it's not ready to be pushed up yet. It's just saying, hey, this version of this file is currently being saved within the staging area. I could still take it out of the staging area and I could put it back in if I want to. I could update it. I could change the information to it if it's not ready to be committed, right? But I'm putting it already in a safe location. So that means there's already a log created for it. If I were to change something and that's not necessarily what I wanted to change, I can tell Git to grab something out of the staging area and reset it back to its original form. So if I were to change this to 0, I could tell it, hey, that's not exactly how I want it to look. I want it to go back to 1. Then I could pull it out of the staging area and have it go back to 1. All right, so that's my git add command. What my git commit command does is
Oh, sorry. So sorry about that.
no problem at all. What my git commit command does is it takes a look at my staging area, grabs all of the files living within my staging area or all of the logs that are currently living within my staging area, and it's placing them within commits. Currently, I'm copying and pasting this. Oh, sorry, these were supposed to be directories. Currently, I'm copying and pasting these directories, but please keep in mind that these staging and commit areas are just the logs itself, not an actual copy of the entire directory or the entire file, right? We're just keeping track of what was changed and it's all being solidified. Well, what's it's inside of a commit and I want to communicate to GitHub. Oh. What I have to do is I have to use a separate command named, too much, git push. All right, so here we can see the little GitHub here on the side. Well, I can use git push and specify the origin. We'll go into that here shortly. But when I utilize git push, what that does is it starts a communication between everything existing in the committed portion of Git, and it pushes it over to GitHub so that GitHub can track the information, follow the directions, and build the copy of what I've created so far. All right, so there we have my Git to project information there. I have my staging and commit area. There's a pretty good meme that kind of shows people, maybe I could find it. I'll have to look for it on the side here and shortly on a break or something. But there's a meme about people boarding a plane, right? So when you do git add, everybody gets on top of the stairwell that's for like loading the plane. I don't know what the correct information is, right? But everybody gets on top of the stairwell. When you do git commit, everybody gets inside of the plane. And when you run that git push command, the plane takes off and goes over to GitHub, right? I'll see if I can find that imagery. It's pretty good. But so far, we've broken down Git in a pretty good style.
I threw something in the Zoom chat that looks similar to what you're saying.
All right. I will have to take a look at it. And then if it's the right one, then I'll post it. Then I'll share it on camera. All right. So now we have all this information here. Let's actually get to practicing it. Again, it's telling me I'm on branch main. I have my README, all this other information, but what is branch main? Oh, go ahead, Brandon.
Could you explain again why like the staging area and why would you just like stage your whole project in order to prepare it to commit? I'm just confused as to why there's like a staging area.
Yeah, that's a great question. Yes, everything has to go into the staging area first before it falls into a commit. The reasoning behind the staging area is, let's say I made changes, I put them within the staging area, right? Everything is there. But for some reason, I have to make changes in a separate file or a separate branch. After I make those changes, I may want to change something in somewhere else within my project, or maybe I want to revert something to a different stage. So the staging area is essentially just for efficiency to protect the commit from becoming way too overwhelmed and getting pushed to GitHub. And its secondary purpose is to protect us as developers from committing something that we don't want to commit and get pushed up into GitHub. All right. A perfect example that I can think of this is, let's say I'm working with something that has a bunch of secret keys. I put all my secret keys directly into my files, and without thinking, I finally got it working. My first reaction is, oh, I should push this up to GitHub. So I do git add. I add my entire project. It all gets placed within the staging area. And right before I commit, I realize, oh, wow, hey, I forgot I have all these secret keys everywhere. Well, I can pull that file out of the staging area to ensure that it doesn't exist anywhere within my Git history, remove those secret keys, and then put it back. Then I could add it to my commit and send it to GitHub. Does that answer your question, Brandon?
So it's like an extra layer of protection.
Exactly.
Okay. Thank you.
Yeah. Go ahead, Erjan.
So how do you take, let's say you're trying to make a change from your project, how do you take them out from the staging area?
We'll be covering that here shortly.
Okay.
All right. Let's go ahead and start falling into what this branch main is, right? So earlier, I believe I was talking to Brandon, and we talked about these different logs and how they fall. And then we talked about how we can change those logs and make an entire new log here. Well, this is a reference to branches, right? So branches essentially mean quite exactly that. When you start your Git history, it typically starts looking like this, right? And this is what we call main. Oh, hello. All right. Well, we don't always want all of our changes or processes whenever we're changing something to fall within the main branch. So what we developers use is something called branches. At some point within my project, I'm going to want to maybe grab the current version of my project. All right, so there I am. I'm basically starting off. Maybe there was a couple file changes prior to, but now I want to make a change to my project. And I know it's going to be a pretty major change, or even if it's a minute change, I don't necessarily want it to live within the main branch because I don't ever want the main branch to have broken code, right? If I'm going to change anything to my project, it should never happen within main, all right? So instead, what I'm going to do is I'm going to branch off. And I'm going to create a separate set of logs that will essentially coexist. Right. And here maybe I don't know, maybe I'm adding like a user authentication function, right? So I'm adding user authentication, and that's what I call the branch. I call it user auth. Typically, you want your branches to resemble what it is that their purpose are for existing, right? Don't try to name your branches something that doesn't make any sense. Just like anything in coding, naming conventions are extremely important for other developers to know what's going on. So I make this user authentication. While this user authentication is happening, I complete it. I say, okay, well, user authentication is done. I'm ready to merge it back up. Well, now this user authentication then falls and merges back to main. And now main not only has the current information that was prior to, so it doesn't just have this block of information. Let's use a different color there. All right, so it doesn't only have the block of information existing prior to me pulling the branch, but it also has the information that I created there in using user authentication. And now all that information is going to carry on for the remaining of the existence of my main branch. All right, this way main was never broken while I was creating this user authentication. Once user authentication was created, tested, and good to go, I merged it back, and then main had that information available to it, allowing me to merge the code. All right, so those are our different branches and how branches are created. Does anyone have, oh, I see some questions. Go ahead, Brandon.
So, I know next to nothing about user authentication. But like for these branches and whatnot, let's say you're running a business and you got a website, and during the holidays, you want to, you know, change up some of the front-facing styles of your website for each holiday, right? Would you have separate branches for each season, for as an example? That way you could like, as you're working, instead of that saying user auth, it would be like Christmas time. And so you'd merge Christmas time to your main, and then now everything looks like Christmas. And then you go back to not Christmas time kind of thing.
So you would do the development process of creating those different themes in branches, but you wouldn't be switching your projects, your current deployed project branch itself, right? So let's say that this one, instead of user authentication, this one is themes, right? Oh, hello, totally erased out, didn't mean to. Let's say I created themes. Well, themes are being developed the entire time I'm writing in here. And I'm creating all those different theme templates to be available.
Oh, okay.
Branch, right? But then it gets
Mhm.
merged back into main. And then
Okay.
somewhere in the development process, like in some HTML template, there would be like if month in, and then maybe a list here of December, January, and whatever else you would like to put in there. Then it could be theme is equal to, and then the Christmas theme object.
Okay, I see what you're saying.
All right.
That makes more sense for me because I can visualize it.
Okay, awesome. All right, so I'll leave that there. Hopefully that helps everybody. Is there any other questions regarding these branching process?
Okay, one more question. Um, so sometimes branches are going to be short-lived, where like you have a branch for a temporary reason, and then there's going to be other times where there'd be like long-standing branches, right? So that they could have different lifespans, but the main branch has, it is the lifespan of the project.
Can I talk into this one just from recent experience, Francisco?
Yeah, of course. Go ahead, Rich.
So as kind of the way we used it is a lot of times within my last software engineering, a lot of times we made our features like, say, for example, the front end needed a change. That would be a temporary short-lived branch. We also had our main branch or production branch, which is what everybody saw. We had a staging branch, which is our basically kind of goof around on, and if we break it, then we can fix it before we break everything branch. And then you have like a testing branch, which is where your QAs will run all their tests and make sure everything works as well. And those are all typically long-lived branches.
Okay.
Yeah, so you may have a few that live for a pretty long time. It kind of depends on what your project's needs are.
Right.
One more question. Are there ever like sub branches for any reason? Just curious how kind of deep down the branch rabbit hole this can go. Like a sub branch of themes, for example.
Yeah, so there definitely is, right? So let's say we have our themes, right? And within my themes, I said, well, I don't just want themes. I also need my theme to I need a theme for fall, right? And maybe my theme for fall works pretty well as a base template. But then I decide that I also need a theme for summer. Oh, maybe a different color would be good there. There you go. And then for my summer theme looks pretty good, and I decide I just want to turn my summer theme into like inverted, and that's going to be my my winter theme. So then there's finally a final branch that looks like this with winter. All right. So that all happens. They all live together. They merge. They don't have to merge necessarily back into one another. This is just the most ideal practice. And the reason why I say ideal is because it would really help with merge conflicts. But again, it's not 100% necessary to do it this way. And then they would all merge back in, right? But it would still cover the same span of information for themes. It's just that there would be a bunch of child branches that continue getting merged into themes. Once themes is completed, then it gets merged back into main. Does that answer your question, Eric?
Yes, it
So-
does. Thanks.
So this actually brings up one more question for me. So using it this way, if I'm understanding correctly, we want to break things down to the smallest possible branch that we can. That way the edits that we're making are confined into a very small space. Therefore, it's easier to debug.
Yeah, so something that I'm always going to bring up is going to be the single responsibility principle. Try to keep anything that you make following one specific purpose, right? So my themes branch, I know that this themes branch exists to manage themes. But if I want to make specific themes, and there's not only one, then within my themes branch, there should be different branches managing each one. Does that make sense, Brandon?
Yeah, so you're basically modularizing your branches.
Exactly. So like
And that way you can put them back together without branch conflicts.
right.
Okay.
Murad, I've seen you had your hand up for quite a while.
Yes, sir. So that's mean this branch is like alternatives, usable code.
Sorry, could you say that one more time? I think I'm having audio.
It is like alternatives. Usable code is like alternative for the code. So at the end,
alternative?
yeah,
You're saying that if it's an alternative usable code?
yeah.
Got it. Yeah, so my main branch never stops existing, right? Even though I'm doing my whole development process here, my main branch never stops existing. I'm essentially just building upon my code base, making new changes, and then putting it back into main in a safe manner.
So the branch is not only for fixing something in the code, right?
Right. It's not only for fixing, it's for
So it has
fact-
so the purposes of the branch may be fixing, maybe making another alternatives, right?
right.
That's what you want to say?
Yes.
Okay, thank you.
All right.
Is there any other purpose for this branch?
Deployment, you typically want, so there's a couple of different branches that are common practice. I don't want to get too much into all those other branches because it could raise a couple of other questions. And I want to make sure that we're staying isolated to the material from today. But
Okay.
there are definitely other branches.
Thank you.
Of course. All right. So now I have my main branch, I have my commits here, and I have my README. Finally, let's start getting some Git, right? So here I have my Git commit, my Git push, and Git add. Well, I've seen this, I see this period here on this meme, and I see a bunch of people. So that means Git add all. Typically, a period at the end of some command means everything. So here I'm going to go ahead and say I want to Git add all. That's going to add my README. If I run Git status now, we can see that it's a different message. So I still see on branch main, I don't have any commits yet. And I see that I have a couple of files here. So now I have a new file readme.md. And we talked about the staging area, right? Readme.md is currently within my staging area now. But now GitHub is giving me a hint, or Git is giving me a hint saying, hey, if you don't want this file in here, and you don't want us to keep track of these logs of what's going on within this file, you can remove it utilizing git rm dash dash cached, and then the name of the file. So let's just put that into practice here. Let's do git rm dash dash cached, and then readme.md. Okay, and we can see that I ran the command, and I see a rm readme.md. Well, now let's see what happens if I run git status. If I run git status, we can see that it turned back into red. I was able to put that file within my staging area and take it back out. All right, so now I can go ahead and add that file again. My file is added. I run git status to ensure it's tracking it. All right, so I did my first portion. I placed my one file inside of the staging area. And I see a question for Orgigin. Go ahead.
Yes. So with the remove the git remove dash cache, would the period also work for like everything as well to remove everything from the staging area?
Oh, let's try it out. I actually don't know the answer to that question. Let's see. Git rm dash dash cached and period. Oh, nope, that did not work.
I think you had a typo.
Oh, that's probably what didn't work, huh? All right, so not removing period recursively without dash R. Okay, so it looks like this could work if you utilize dash R. I don't recommend it. You typically don't ever want to remove everything straight out from GitHub, or straight out from Git if you've already initialized it. But let's try it out. Let's see what it does. Oh,
I'm not sure if it lets you without. Oh yeah, there you go.
yeah. So I was able to remove the README, and I'm sure that if I had a ton of other files, it would have also removed them as well. Does that answer your question, Orgigin?
Yes, thank you.
Of course. All right, so now we've gone over putting files within the staging area, removing them out of the staging area. Well, how do I place them inside of my commit? All right, so here I have my git add. My git add is done. All the people are in the staircase. Now I want to place them inside of the plane. All I'm going to do is I'm going to write git commit. And this part's actually really important, right? You could just run git commit dash a and it'll make a commit for you. But you actually want to do something called dash m, and that stands for message. So just like we talked about earlier, everything within GitHub is a series of logs, all happening within one another. But we also spoke about naming conventions and why it's important to have those naming conventions. Well, me as a developer, I need to know what exactly each commit puts my project at. Otherwise, I'm just going to be looking at a series of numbers over and over and over again. Let me go ahead and pull that up here for everybody. I guess our curriculum is probably not the best one to show our commit history in, but why not? All right, so here we have a series of commit histories, right? We can see.
And Len, thank you. That is the commit I just made for the based on your feedback.
Nice. So here we can see a couple of different pull requests have been made. Here we can see all the commits from June 4th, which that's today. Adam has been very busy this morning.
Either of those two commits will be good to look at if you want to.
All right. And then we have a couple of other commits as we continue going down. But we can see here that all of these messages are really useful for me, right? Well, what would happen if these messages weren't there? Unfortunately, I don't think we have an example where messages wouldn't be there. But what we would actually see is rather than seeing this merging main into AI curriculum changes, we would just see a series of numbers, right? Which is not useful at all. It doesn't really matter to me if I see this in this series of numbers. If I'm in trouble and I need to make sure that I go back to a current version of my project that is good, working, something that I can interact with, well, then a series of numbers isn't going to help me at all. Instead, I need messages that tell me, hey, when I committed this or when this commit was made, this is the progress that we made so far. All right. So again, I'm going to utilize git commit -m. I just initialized, so I'm just going to say init. That's all I did. Now, the only naming convention that there is for commits is that they should be oh man, what's it called? They should be like present tense and they should say what they are accomplishing. So for example, when I finish completing these themes branch and all the themes have been merged, I would name my actual commit of all themes completed or adding themes, right? It's the verb of what it's supposed to be doing and then the noun of what it is that it's doing. And you want that to be I forgot the correct word. I apologize to everyone. I struggle with my English every now and then. But it's supposed to be like an actionable way of naming it. Right. So now I have my git commit, I have my message, it's all ready to go. I've committed, my information is ready to go, and now it's ready to go to GitHub. Well, it told me I was on branch main. Let me check what branches I have. And the way I could do that is by running git branch. So here we can see main, and we'll go into how to make different branches and interact with them here shortly. All right. So again, I'm inside of GitHub. If I do git push right now, it's going to tell me that I have an issue. It says, hey, we don't have anywhere to push this information to. And it gives me a pretty good hint as to how I could specify where I should push this information to. All right, so now we have to clean the communication between Git itself and GitHub, because Git keeps track of my project by running git init and creating that directory, but it never knows how to communicate with GitHub unless I told it how to, or unless I grabbed all the information from GitHub first. So let's start there. I see a question here on the chat. We have git commit will move everything from staging to commit. No specifying the files via name with a dot. Yeah, that's a great question. When you utilize git commit, it's literally taking everything from the staging area and making a solid copy that will get sent to GitHub. So no, there's no specifying of solid files. Does that answer your question, Eric?
Yeah, thanks.
Of course. All right. So now you'll notice this isn't green anymore. Everything's ready to go, but I need to tell Git how to communicate. Well, let's go ahead and kick into that process here. I'm going to go over to my repositories. There's probably an easier way to do this, but I can click new. Well, when I click a new repository, I can come down. It's going to ask me to choose the owner. Unfortunately, I'm part of a pretty large amount of organizations, which I need to clean that up. All right. And now it's going to ask me to choose a repository name. So I'm just going to put learning Git here. All right. So this is going to be my repository name. So now it's going to ask me a couple of questions here. It's going to say, hey, is this repository meant to be private or public? That's pretty self-explanatory. Public, anybody can access it. Private, only people that I want to access it, that I manually add into this repo and actually see it. All right. Brandon, go ahead.
Is there a naming convention for repositories?
It's a great question. When it comes to naming conventions, no. I would just say to name it the same thing that you're naming your project within your local desktop or your local machine. That way there's no like confusion between them. Does that answer your question?
They also generally have to be URL friendly, but in most cases it'll auto format that for you.
All right, perfect. Yeah, so if I were to do
So-
something like
Sorry, just a quick question. So that git init command doesn't create the empty repository in GitHub. It only creates it in your local machine. And then you have to manually go over to GitHub to create it. Is there a git command where you can run in the terminal to create the repository in GitHub?
That's a great question, Joseph. And there's not a git command. There is a gh command, right? So gh is a completely different tool than git. You could utilize gh to create a repository, but git doesn't work that way. You could tell Git where to communicate to in the URL, but you can't tell Git to create a repo for you. Does that answer your question?
Yes, thank you.
All right. Daniel?
Yeah, so just for clarification, so when we're pushing our files with Git, we're actually just sending the logs itself, not the files, right?
Exactly.
And then the logs are the directions for GitHub.
Yes.
Okay.
All right. All right, so now just like was that Rich earlier? So Rich mentioned, he said, hey, your repositories usually have to fit some sort of URL friendly. Here I can put this is awesome, and it just says the repository name can only contain a SSI character, digits, and the characters space or whatever. So sometimes they'll just update it. So here we can see your new repository will be created as this is awesome. So it changed it and put some differences there. But let me go ahead and change that back to learning Git. I have my public repository. And yes, GH is GitHub CLI. I apologize to everyone. That was a question on the chat. All right. But this part's pretty important. So here it tells me, do you want to initialize this repository with a README? I do not, right? I do not want to initialize this repository with a README because I already have a README in my repo, in my project, right? I don't need another one. I already have one. If I try to create another one, it's going to make the initial commit for me. And I don't want that, right? Because as we talked about it before, where's our drawing? All that Git knows is previous and the logs that it's tracking on, right? That's what each individual log knows. Previous and the logs that it's tracking on. If I create a repository with a README, then my initial log has already been created and made for me. So when I clone it down or I try to connect it to the one working on my desktop, those two logs will be conflicting with one another. I'll have two different sets of initial logs that won't actually talk to each other. So because I don't want it to have an initial log, I am not going to add a README. I don't need to git ignore, which we'll talk about later. I don't need to worry about licenses. At this point, I'm good to create a repository. Okay, so now I have a repo. And give me a second, Red. So now I have this repo here, but this repo doesn't actually have anything in it, right? Well, it gives me a couple of options as to what I can do. It says you can grab this. This is the process. You can make an init. You can add a README. We've already done this. We've made a commit here. We know we're inside of our main branch. And now look, here it gives me a very specific information on how I could add the remote branch, right? I can also do this by just copying the HTTPS. And I know that to attach this branch, well, I can say git remote. And if I do git remote -v, that should tell me the current remote branch that I'm in. I don't have one. So I'm going to say git remote add origin. And then I'm going to go ahead and paste that URL.
Origin spelled wrong.
Oh, thank you. Origin. There you go. All right. So now if I run git remote -v again, here we can see that I have my actual origin. And I have one that's misspelled. That's okay. It's not going to interact with anything. But I know that this is the correct one, the one that says origin, and it's all attached to the correct information. All right. So now I can say git push origin main. And now we can see a couple of things were pushed. We can see that I have, it tells me the specific space that I'm utilizing. There was 3 objects already created just from adding that one README file. It utilized 203 bytes, 203 KIBS, and then it tells me it was done. All right. Well, now what happens when I refresh this page? When I refresh this page, I am now within a repo that belongs to me. And all it has is my one empty README. And if I take a look at my commit history, we can see that the only thing inside of my commit history is init. All right, Murad, what was your question?
I just want to know, this is a different question. Is this how we pull the last step, how we pull the repository from the GitHub to Git? That is different?
Yeah, so currently we're working on creating a repo and pushing it up to GitHub. We haven't covered how to pull from GitHub just yet.
So this is not how to pull it. Okay.
Right. All right. Any other questions?
Could we quickly go over the git remote add origin
Yeah.
command again?
Definitely. I'm actually going to put it in here so that it's visible. And you know what? This little square isn't cutting the cheese. I'm going to go ahead and go with something like this. Okay, so we have our git commit. And before I can do a push, I have to tell it a remote branch. So it's git remote add origin.
What is the naming convention for this? So git remote. What
Oh, sorry, go ahead.
so like git remote, what do they mean by remote there?
Yeah.
Is that
So git already is a tool, right? The next command there is remote. Well, remote means that it doesn't exist within my machine. It's not something here that my machine's actually talking to or communicating with. It's something that lives outside remotely, right? It's a cloud, some sort of server out there, but it doesn't know where to talk to it. So I need to give it an origin. So then I use the add command saying, I want you to add the following URL. I then specify this is going to be an origin. And then I want you to have the actual URL that comes from GitHub. And that's where we'll be pushing. So when I get push origin main, it says I want to push to the remote branch named origin, and I'm going to push it to the main branch of that URL.
okay? Are we gonna be going over how to change that origin URL if necessary?
Yeah, we definitely can.
Okay.
Yeah. All right. Let's go ahead and continue on with this process here. Is there, oh, actually, is there any other questions before we move on?
Yeah, I just wanted to make sure. So the remote is you actually taking that and then pushing it to GitHub. So you created the remote repo and then push that to the URL in GitHub. So what you were seeing was what you're seeing on your terminal there is what was on the GitHub itself.
Right. So what I'm seeing here on my terminal are the directions that got pushed up to GitHub. And what I'm seeing in GitHub is the product of those directions. Right. So I followed those step-by-step directions, and it determined that all it needed to do was have an empty README file within this one repo.
Got it. All right. Thank you.
Of course.
And we're just pushing the main because that's the only branch we have, right? Like if we were working with other people on a project, you'd probably push it to some other branch off of main, just not direct from Git, right? Okay.
All right. Awesome, everyone. Well, we've been going for quite a bit. Let's go ahead and take an 8-minute break, and let's come back at 10 o'clock and continue on with our lecture. Thank you so much, everyone. See everyone here in a bit. Sure. All right, welcome back, everyone. So far we've gone over how to push all of this information over to GitHub. This is working pretty great. Got everything there. But there's definitely a lot more that falls into Git, right? But we talked about branches, how to work with them, how to make a couple of different things. So let's go ahead and make a branch here. I'm gonna go ahead and pass Git branch. But when I pass Git branch, it tells me that I have main. So what I'm gonna do is I'm gonna try to grab a separate branch. In order to do that, the command that I'll use is git checkout. So let me actually come here. Gonna come down to our different branches down here. I'm gonna put git checkout. Grabs other branches. All right, so get checkout will try to grab another branch. If you want to create a branch at the same time you're trying to check out a new one, you could pass in the -b argument. So I'm going to say get checkout -b. That tells Git, hey, I'm going to create a branch here. And this one's just going to be named adding, I'm going to say readme content. All right, so now it tells me you switch to a new branch named readme content. Well, let's run that git branch command one more time. And now we can see a list of branches. I have main and I have readme. This little asterisk here and the fact that readme content is in green tells me that I'm currently within the readme content. And let me add that as well. Git branch lists all branches. All right. So now I have my readme content. And here I can add a couple of different things. Let's say, okay, we're gonna put learning Git. Gonna put my lesson here. I'm gonna say we are actively learning how to get Git. It seems a little magical, but it works pretty well. All right, so now I've made a couple of changes here. And there's a couple of color changes here on my files. All right, I can see that my file has now changed from being solid white or solid green to being yellow. And I see an M right next to it. All right, if I hover over it, I get a little description here. It tells me it gives me the path to my file. And then it says modified. So this has been modified. Okay, great. Well, what does this tell me? Or what do you would think is happening here in our structure? Can anybody describe to me why I got that modified and what exactly is going on here?
Is it in the staging area?
I think that's the. Oh, sorry. Yeah, go ahead. I'm sorry.
Nope, you go.
Now no one's gonna go. All right.
A new log is created.
Yeah, perfect. So, oh, and I see someone in the chat as well. It's different from the saved version in the last log. Exactly. So a new log or Git is keeping track of that information, and it's actively writing a new log for this one file, right? Well, if it's actively writing a new log for this one file, I know that I haven't placed that log within my staging area or my commit area. So if I run git status, I should see that there's something not inside of my staging area or commit. And there we can see it in red letters again. So git status, something has been modified. It's my readme, but it is not within my staging area. This log hasn't been added to my staging area, and it hasn't been added to my commit. So let's go ahead and do that. I'm gonna git add my readme. And then I'm gonna go ahead and commit this file. So notice that even though I added it, nothing changed. It's still telling me that it's been modified since the last one. Where it changes is once I commit. So commit -m add readme content. That's what this commit does. And once it's been committed and solidified, well, now that log gets put into the safe area of, hey, this is now committed. We don't need to throw any alerts for it. And now it's no longer highlighted with an M. Go ahead, Tim. You're muted, Tim.
Yeah, sorry. Why is it go to straight to commit and not to stage first? You just committed it without going to stage.
Yeah,
That's my question.
So when I run this git add readme.md, that's what puts it inside of the staging area. So adding it, placed it inside the staging area, and then running this commit command puts it inside of my commit area. Does that answer your question?
Thank you. Yep, thank you.
Of course. Go ahead, Erica.
If you want to, oh, I wrote it, but if you want to add multiple files and that are like interconnected or anything, but you don't want to add all of it, do you have to add them file by file?
At that point, it kind of depends on how you want to do it. You could either add all of them and then remove the specific files that you don't want to be within the staging area. But if you're doing the picking and choosing game, it does turn into a hassle. There's no quick command to specify a range of files that it should be committing or not. Does that answer your question, Erica?
Yeah.
Of course. All right.
Question. What's the -m flag doing there?
Yeah, so that -m flag is what allows me to write a message. So the git commit works on its own, but the -m is what allows me to actually add a message to this commit content so that my log is not just a series of numbers. And this is actually a perfect time to talk about the log. Let's take a look at our log before I even push this up to GitHub. I'm going to run a command named git log. All right, so we've talked about the Git history, or we've talked a little bit about all the different commands here. We talked a little bit about branches and how they exist, and I specified how this works as a version control. But I never specified how exactly we can move between these couple of items here, right? So now, when I ran the command git log, what you're going to get is a record of all of the logs that exist for this one repository up to this stage. And you can continue just scrolling down. Currently, I only have 2. So as soon as I pressed entered, it kind of knocked me out. But here, when I ran this git log, I can see the commit and then the entire series of numbers that comes after it, right? As we've previously mentioned, this series of numbers is pretty much useless as far as telling me what exactly is happening within the log. But it is useful for reverting back to a previous stage. All right, so let's take a look here. So I have my log, and let's say I'm currently working within my author. That's me right here. And here I have a README content. It's showing me all of my different logs here. Well, what if I don't want any of this information to exist anymore, right? I want to go back in history. I want to go back to where I had an empty directory. Well, you just have to take the first 5 characters of each individual log, and that's enough for Git to identify the entire log here. So currently my head, and I'm going to go ahead and utilize a star here to represent head. Let's make this a gold star, because why not? All right, so I made my initial commit, and then I made a separate commit named add readme content. Well, this separate commit only knows about its previous, right? So it's only showing me the previous commits before it. So I know that there's a way of communicating where I can go back in time. I can come back to that commit before. Well, that same command that I utilized to grab a branch I can use to grab a specific commit. So I want to go back to this one, 4CF32. There's my 5 characters, and I'm gonna run git checkout. And when I run git checkout, and actually I'm gonna keep track of, when I run this git checkout command, well, we can see that I went back to being an empty commit, right? It's not an empty commit, I apologize, to being an empty file. Well, that's because I moved my head, my current location of my project that I'm looking at, back one. I'm looking back at my empty file at that point in history where I created it. I'm no longer at that point in history where I was before. And let's try to read this through this, because we want to make sure we don't just do things and leave it there, right? So now it's telling me, hey, you are now in a detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by switching back to a branch. So this log here exists within the main branch, right? But the log itself is not the main branch, right? The main branch is a series of copies of these logs, but it is not the actual log itself. So when I went back here to this previous log, it puts me in a headless state, or a detached head state. Now, what that means is I can maneuver around, I can change code, I can break my code, I can fix it, but it's not actually being placed anywhere. I can save that code in a separate file that I changed. Maybe I want to go back and make a couple of changes that are experimental. Maybe I'm trying to make something a little bit more efficient, but I'm not sure if it's going to work. I just want to play around with it. Well, if it does work, I'm just going to copy and paste that, put it inside of some TXT file, come back to my original branch, maybe make another branch to add that one specific change, and then place it on there. But this is a way that you can view what your files look like in previous states or in previous logs of its history. All right, the main thing that I want to make sure that everybody understands is this is not going to impact any branches. So any branches that exist, if you make any changes to your documents, whether they're good or bad, they are not going to be saved or placed into the current version of your branch. All right. I can't emphasize that enough. This is not going to impact any of your currently active branches. Go ahead, Tim.
Unless,
My question is, does it update the log though? It doesn't update the current version, but does it update that, say, the head of the log? Is it going to change that initial file, but leave all the other ones the same?
Yeah, that's a great question. And give me a second. I'll get right back to that question. Brandon, I think you have something you want to add?
I was gonna say it won't change it unless you commit it.
All
'Cause
right.
it's,
So that
is that true?
that ties into it. Yeah. So
Okay.
exactly. So now here, right below, it follows into the next portion, right? If you want to create a new branch to retain the commits you create, you may do so now or later by utilizing -C with the switch command. And then it gives me an example. So it tells me I can make some changes if I really want to and make a completely new branch. But if I do that and I make a completely new branch, I need to utilize a separate command named switch-C and go into that command. I'm not going to demonstrate this, and we're not going to actually break this down or go through it because it's not very good common practice, and it's also not something that we're going to be practicing very often here in the cohort, and it might just be way too much information at this current time. So currently, the one thing that I want everyone to focus on is if you want to see a current version of your project at a previous time, you can go ahead and go back by checking out the log. Does anyone have any other questions?
Yeah, so I was going to ask why not just go back to the the edits you just did and not do the git switch? Like when's a particular time would you do a git switch? Or was it a perfect scenario, I guess, to do one?
I guess the one thing that comes to mind is, let's say you build up a considerable amount of technical debt. There's a new version that comes out. And there's a couple of changes that you want to make, right? You could either make an entirely new branch, or maybe something was working before, and it should have continued to work, and for some reason it didn't. Then maybe there's a conflict between different branches. You could check out a previous version and then make an entirely new branch that will override the one that already exists, or that you'll use instead of the one that already existed before. That way you can clean up and maintain that branch with the newer updates. But there's really not a huge necessity for actually putting this into application. Does that answer your question, Chris?
Yes, sir. Thank you.
Of course. Erica?
Wouldn't this be a rollback when there's a bug that like it's breaking, basically? In the case of a game, you break the servers, down for maintenance, roll back to previous version.
Yeah, that's a pretty good example, right? Let's say I completely have it messed up. I could go back to the previous version and make that my new head. So I could establish this as my new head and just get rid of my changes before. Gary?
Yeah, could you scroll up in your terminal for me so I can see where you did checkout, just so I can look at the syntax?
Yeah, of course. Here it is. So git checkout, and then the first 5 letters of that commit code.
Okay, it has to be the first 5, or is he just looking for?
It's a minimum of the first 5, yes.
Okay. All right, and then my other question was, can you see the status of your what's the word? I forgot. Where right before you commit, the index, can you see that? Like what everything that's in there before you actually commit it? Like, can you look at like what is like pending to be committed? Is that like a thing you can put in, like get index status or something like that?
I could still run git status at my current state. So I'm currently in a head that's detached at 4CF32, and it tells me there's nothing to commit because I haven't changed anything. Does that answer your question?
Yeah, just like if you're working on multiple files, would you be able to see like, everything that was not committed yet? Like I know like you're looking at this exact like file right now, but like just in general.
Oh, yes, you can. You can utilize something called git diff, and I see Adam messaging me here on the side. He's trying to tell me.
I wasn't sure if we want to open the door or not.
Yeah, there is a command that you can utilize for that. And if I could get through the content here, we'll go back and we could take a look at that git diff command and how it works. But for now, I'm
Okay.
gonna put that question in my back pocket if that's okay. Of
No, that's fine. I was just curious. Thank you.
course. All right. So currently I have a couple of branches here. If I do git branch, you can see that my branches still exist. Currently it's telling me where my head is located, but I don't have to pay attention to that. I can go back and do git checkout, readme, content. And now I can see that I have back all of my readme content. Do you have another question, Gary, or is your hand just still up?
No,
Oh.
sorry about that. Yeah.
That is so nice.
Awesome. All right, so all of my versions is still there. I still have all of my information. If I run git branch one more time, we can see that that head that was detached is no longer being tracked. It just put me back to main and readme content, all right? If I run my git log one more time, it's still going to show me my 2 commit histories, or my 2 different commits, because that's all it's tracking on. And it's telling me, hey, my head is currently located on the readme content branch at this current log. So I just went back to my log. All right, awesome. Well, we're going to do 2 things here. The first one I'm going to do is I'm going to push this up to GitHub. But when I push this up to GitHub, I'm not just going to do origin main as before, right? Because as we know, where did that command go? Here we go. Main was the name of the other branch that I had, right? So I have main, and now I have readme content. So instead, what I'm going to do is I'm going to push it to my branch name. So that's an argument. So git push origin readme content. Now, when I push this, where it's going to do a couple of things. This is going to be a little bit of a larger push. So we can see that it has 5 objects. Those 5 objects were now added. We're not going to go into how these objects are going to be built because that's pretty complicated as how those objects are built. Those are essentially the directions that fall inside of a log. And we can see that it actually creates a pull request for README content on GitHub, or it's telling me I can create a pull request. But there's a new branch that was created on GitHub. So let's take a look at GitHub. All right, so here I see a pretty big message from GitHub saying, hey, we got a new branch. Its name is README content, and you can compare and do a pull request. Well, let's take a look at that. Currently, it doesn't show it there. It's because I need to refresh. It's a little odd that they have this function working so well, but not this. So now if I click on this drop-down menu, we can see that I have main and README content. Well, let's take a look at the README. So my README on branch main is still an empty README. There's nothing. It's empty. But if I go to my README content, now I can see that my README file does have some content, right? It has my learning Git, my lesson, we're actively learning, etc., etc. It's all in there for me, currently placed out so that I can actually compare those 2 branches from one another, all right? All right, any questions up to this point before we start going into merging and pull request?
There was a question in the X-ray questions channel. I'm currently in main branch. I check out a different branch. I do some work. I add some files. I commit the files. Is that a good idea of the workflow?
Yeah, so typically your workflow would be your main branch should essentially never be touched or never be changed by you yourself. If you're going to do something to the main code base or start the main code base, you start a branch, develop some code, and then you merge that branch back into main. Does that answer that question? I think that was Brandon.
Yeah, absolutely. I was just making sure I have a general idea of, you know, when I'm at the workplace, and handling all this stuff.
Of course. Yeah, that's a great question.
Yeah.
All right.
The only thing for daily assignments, you all may end up doing work on the main branch. That's the only thing I wanted to run there.
All right. So now that we have all this information, we can do some compare and pull requests. So there's a couple of ways to do it. You can do it through GitHub, or you could do it through your terminal. Doing it through your terminal works, but it doesn't work as intended to. So this is what I mean. And I apologize, Adam, for throwing this on you last minute. But if you could go on GitHub, I'm going to add you as a collaborator, and then we could demonstrate the whole pull request process, right?
Yeah, totally.
So currently right now, my thing is unprotected. Please don't worry about this collaborator process. It's not necessary for what we are doing. But I'm just going to add Adam here as a collaborator so he could give me some guidance as far as some clean code if possible. So I'm going to add Adam.
And give me just one moment to accept that invite.
All right. So Adam will accept the invite. And while
I know there's a way to do it in GitHub. I always have to go to my email.
So in order to do that, and while he's doing that, I'm going to go ahead and start this compare and pull request process. So now it's telling me I have these 3 pushes. It was done, or I have this one push. It was done 3 minutes ago. And it's telling me you could create a pull request. Well, let's take a look at what that looks like. Well, it's asking me, what is it that I want to name this pull request? And this top portion isn't too much, right? So I could say just a quick description of what this lesson is going to accomplish. right? And it's always preferable to add a description here. If you're working on an actual development branch, or an actual feature, I strongly recommend that you put bullet points of what the features do. So for example, if I was doing user authentication and I was working on the backend team, I could say API endpoints created, and then maybe under I have like a list of all the API endpoints that were created, and so on, right? We'll get into this whole thing, us building upon each other as we continue within the course. So now I have this information, but let's take a look down below. What is happening? All right, so it's telling me there is one commit that I'm going to be adding to my main branch. My main branch was not tracking on this one commit. I'm adding, and it's telling me that this one commit only had one file changed. And then how many people changed that file? So there was only one person that worked on this branch, which was me. I only changed one file, and I've only added one commit. Well, that adds up, right? If I take a look over here, I look at my Git log. Well, on my Git log, I only have one commit that I added other than my initial one. And I did only change one file, which was my README. Well, let's see what else it's tracking. Well, now it's telling me these are the changes that have happened. There were 7 additions and 0 deletions. So if I were to delete anything from a file or change a line, so let me rephrase that. If I were to delete any lines from a file or change a line within a file, it would be tracking what's happening. But these additions is only tracking lines of code as well as deletions. So I'm adding 7 lines of code here. It looks exactly like what I wanted it to look like, and it's all been done. I can create my pull request now, but before I go to create my pull request, I'm going to go ahead and add a reviewer. In the actual workplace, more than likely you'll already have reviewers set to you or somebody that is actively looking at this information as soon as you push. This might be automated. But for now, I sent an invite for a review to Adam. I'm going to create my pull request. My pull request has been created. And now let's see what's going on here. So here's what I left as the comment for my pull request. I said, this is just adding a quick description. It has my list of examples, and then it has my commit. All right, and then it says, this is the commit that I'm trying to merge. This is where the point of merge is happening. And I've now requested a review from Adam. All right, further down below, it's going to tell me, well, this is working well. There's no merge conflicts. There's a review that was requested, but just so you know, there are no conflicts with the base branch, and you can merge this automatically rather than going into the merge console and doing all the difficult stuff. So now we're waiting. At this point, Adam is likely working through and trying to add a comment somewhere.
Yep, ready. Let me know if you want me to share my screen or what you'd like me to do.
No, if you could just make the comment, that would be great.
Got it. And I see as I'm making this comment that we have a question.
All right, go ahead, Brendan.
So just because GitHub says that the merge can be done does not mean something won't break.
Something
like, yeah, like when this merge, so like if we were using this on like a code base and it says the branch has no conflicts with the base branch, something could still break when you do that merge, correct?
Got it. All right. So let's talk a little bit about merge conflicts. So what GitHub and merge conflicts actually are, or what it's analyzing for, is it's ensuring that the current code that you're trying to throw into the existing branch follows the same set of directions, right? As we talked about those different logs, the logs are essentially just directions. If at any point the directions change between those two separate branches, and they don't fall together, like they're saying, hey, my directions are different from what I was told from this prior log compared to the log that you're trying to throw in there, it's going to tell me that I have a merge conflict. It's not analyzing your syntax of your code. It's not analyzing whether your code is functional or not. It's essentially saying, can I follow the directions that these two branches are giving me effectively and turn them into one?
Okay.
If you can, then it will say that the merge is that you can merge them automatically and that there are no conflicts. If it cannot follow those directions and merge them into one, then it's going to tell you that you have to fix it and you have to manually go through the merge conflict terminal.
Okay.
Awesome. All right, so it looks like our comments have been added. Let's go ahead and refresh this here. All right, so I got a comment there. I see love it, looks good to me. So I get a thumbs up.
And there's a comment on the code itself if we want to see that.
Oh, nice. So it looks like we got a little bit of a comment on my code itself. Let's take a look there. I don't see a
Files changed, or wait, maybe I have to finish. I apologize. I had to click submit review.
There you
Now I think you should be able to see it.
All right, let's refresh this one more time. And now here we see love it, looks good to me. And then here's the review. So great idea, looks good to me. If I wanted to share code, I would wrap the relevant text in three backticks without spaces. So print hello word, and we could discuss code. All right, great. So it looks like everything's working correctly. I have all the information that I need. This doesn't really have any actionable comments, and unless there's something actionable, I typically just resolve the conversation saying, all right, well, thank you for the feedback. Nothing was actionable. I'm going to go ahead and merge my request. I can confirm my merge request, and give me a second, Connor. So now, if I look through it, we can see that everything was passed in correctly, and everything was now merged into main. So if I go back to my code, and I take a look at my main branch now has all the updates from my README branch. All right, Connor, go ahead.
Yeah, so I was actually wondering about collaboration on larger projects. So like on a small project where it's like a handful of developers, each developer making a new branch every time they want to add a feature and then making a pull request, that makes sense. But let's say you're working on VS Code project or React or something and you have a million developers. Is there a different process like forking the repo and then making a pull request, or how does that work?
Yeah, that's a great question. And we're going to be going over that this afternoon over how to clone projects. But as far as the branching process goes, it's still the same process. You're going to create a branch, make your development, and then get ready to merge it. The problem is that merge conflicts are pretty much inevitable. You're going to go ahead and run into a merge conflict at one point or another. And you want to make sure that you keep a very clear line of communication with the entire development team as to, hey, I'm grabbing this branch, checking it out, and I'm going to be making some changes to it. I see your question up, Connor. Do you have something you want to add? Or was that from prior? No. Your hand's up, Connor. Do you have something you want to add or no? Oh, okay.
I thought my bad. I thought I had lowered it, but whatever. You don't
Yeah,
have to move into it.
I think it lowers when you're done talking.
All right. Yeah, did that answer your question, Connor?
Yeah, partially. I guess we'll see later.
Okay, awesome. All right. So now that we have this information, I have everything merged, everything's good to go. Let's take a look at what it looks like on my local machine. Because I made these changes in GitHub, but not in my local machine, right? If I do git checkout main, and if I do git checkout main, we can see that I don't have any of the changes. Well, the merge request happened inside of GitHub. And if we take a look back at our communication flow, changes that happen within GitHub don't necessarily reflect back to my machine. Just like I had to tell Git to push things up to GitHub, I have to tell Git to grab things from GitHub. So all I'm going to do here is I'm going to say git pull origin main. And once I pass that command, I get all of the changes from GitHub. And now my main branch is up to speed and reflects exactly the same thing that is on GitHub. All right. Does anyone have any questions over this process?
Do you use git fetch to check before you pull?
And you can utilize git fetch, yes. If utilize git fetch is going to grab, oh man, I'm gonna have to get back to that question. I typically always utilize git pull. I know git pull and git fetch work differently, work similarly, but there's a vital difference between them that I can't remember off the top of my head, and I really apologize.
I think fetch just shows you the difference and pull just incorporates them.
Got it. Okay. Perfect. Do you by any chance know, Adam?
What was the question again?
Git fetch and git pull.
Oh, I believe git fetch gets a list of new branches, and if a branch has changes, but let's say, Francisco, you and I are working on our branch, and Francisco, you've pushed a massive new feature. If I run git fetch, it tells me that our branch has changed, but it doesn't actually get me your code. If I run git pull, it actually pulls down all the changes on a particular branch. I'm not 100%, but I think that's correct.
There you go. All right. Thank you, Adam. I appreciate that.
My
All
pleasure.
right. Okay, so we've gone over quite a bit of information at this point. It's super important that we practice this. Now I understand that we don't necessarily have too many exercises for everybody to practice, but we're gonna go ahead and break at this point. It is 10:38. Let's break for an hour and come back at 11:30. And let me pause the recording at this point since we're not covering any more content here. All right, welcome back, everyone. Before we left from part one, we covered how exactly Git works and how we can tell Git to keep track of different files, create branches, what our logs are, what is the Git is actually tracking, and how it communicates with GitHub. And we covered a couple of Git commands. Now, everything that we've covered up to this point has been from our machine to GitHub, but we haven't really talked about how do we get GitHub to communicate to our machine? The other way around, right? All we've seen so far is this git pull. Well, let's talk about the different things that GitHub has to offer for us. So if we go over to GitHub, there's a couple of different ways that you can actually, I guess, manipulate or interact with GitHub. One of the easiest one is going to be to fork. And it's likely not an option for me due to some assignment stuff. So let me go ahead and take a look here if I can get to a good repository.
Do you want me to?
I apologize, everyone. I'm gonna have to pause the lecture here for a quick second while I take care of this little one. Recording here. All right. So we're currently in GitHub. Again, we're going to be covering about the communication between GitHub and our own repositories. So let's go ahead and go into, let's try this one. Let's try Python and PyTest. If I scroll down, I can see a couple of little assignments here. If I click on one of these assignments, it takes me to a repository that already exists, right? So this repository exists within GitHub. Well, how can I grab it? Sorry, everyone. Let's go ahead and I'm going to click on this fork here. So now I am forking this assignment. And what forking is actually doing is it's creating a copy of these repositories. So if I were to grab GitHub here, and let's try to expand this a little bit. Well, now GitHub has a considerable amount of repos inside of it. Right, so here we can see all of our repos there.
Yeah, I want it.
All right. So let's say that there's these 3 repos. Well, these 3 repos don't necessarily belong to me. But they are repositories that I want to be able to interact with, maybe clone and make my own. So these 3 repos belong to their own organization. Right, so there it is. And now I want to make one of these repos my own organization. So let me go ahead and make this a different color there. And all I essentially want to do is I want to copy and paste that same repository to belong to me. All right, I want it to be part of my org. Well, all I need to do is fork the repository, just like I did before. And let me actually go back here. So again, this Algo 99 bottles belongs to Code Platoon assignments. I'm going to fork this assignment. And I'm going to make myself the owner. So I'm copying and pasting that one GitHub repo into my organization. All right, now when we can see here that it says copy the main branch as well. I could take this off and it would copy all of the branches, but typically you just want the main branch. All right. Now I'm going to create my fork. Well, my fork is happening. It's creating its own process. It's going to take a while. And now we can see that my organization or my profile, Fravela08, has the same repository of this one fork. All right, this is great. Now, I'm sure everybody by now has heard about forking, right? Well, forking, everybody now has heard about cloning. Well, now forking and cloning work almost exactly the same with one very specific difference. When you fork a repo, you're actually keeping track of that parent repository that you forked, right? So I forked the repository, but it's always going to continue looking at its parent repo for any updates, right? So that's where this syncing here comes in place. So it tells me, hey, this is currently this is what's going on there. If any update were to happen to this assignment, which let's see, for practical application purposes, let's say that I'm going to go ahead and make a quick change here. There's no considerations, so maybe I could just add no considerations at this time. I'm going to commit my changes. I'm going to commit them directly into my main branch. And I see there are some rules there, but I'm bypassing. All right. So now I made some considerations there. It looks like there were some, but I didn't see them. So I put no considerations at this time. Well, if I go back to my repo, and this might be more effective if I open link in new tab here. And go back to my repositories here. Well, here's my repository that I forked over. If I come down to considerations, we can see that it doesn't say anything regarding this consideration stuff, right? Now, keep in mind, I'm not actually interacting with them throughout Git. This is all happening through GitHub. Well, if I wanted to sync these or get the most updated version, I could click on sync fork. It tells me, hey, this branch is out of date. And that means that the current version that I have doesn't match the version that I forked. And I see a question here from Len. Go ahead, Len. Oh, you just have your...
I have no idea how that hand got raised because that was...
Oh,
sorry.
All right. Yeah, no problem at all. Well, now it tells me that I'm exactly one commit behind. Right, so let's go ahead and sync these branches. I'm going to update my branches. And after I update my branches, it worked almost like a merge. All right. I now have the no considerations at this time, just like I did in my algos over here. All right, so that's the very key difference about fork. When you fork, it's always going to continue keeping a track of that repository that you forked from. And it's probably the easiest way to actually get a copy of any of the assignments or anything that we work through here in Platoon. That's pretty much it for forking. Does anyone have any questions regarding how to fork and how fork works?
Not a question directly related to forking, but related to assignments. So for assignments, are you expecting us as like a best practice to fork each and every single one of them and then have like 180 repositories in our GitHub account? Or can we just like have like a folder on like locally and then we like clone each one individually and then just track it as like one massive repo with all the assignments in it?
Yeah, that's a great question, Connor. So when it comes to the assignments and how we want them to be handled for everyone, we strongly recommend that you either clone them or fork them and create individual repositories for each one of the assignments. Now, the reason behind this, you may think, well, that's going to make a hassle because now I'm just going to have all of these different repos inside of my GitHub repository, or maybe that's going to create all these different directories inside of my laptop. And yes, you're effectively right, but it's also going to build your GitHub profile presence. It's going to show the different commits that you've done inside of GitHub itself. Let's see if I can show you mine. Inside of GitHub itself, it tells you, it gives you a couple of different things depending on what you've done within GitHub. And it's important to build your presence by making different repositories, having different commits in there. Here it tells me a couple of popular repositories, and here is the important part, right? So here's where people can see how often is it that you're pushing or committing to GitHub. And as you can see, apparently I'm really spotty in September and around the holidays, which is to be expected. But if somebody were to take a look at your random GitHub profile, let's say they spiked an interest in you as a developer, they want to take a look at who you are as a developer, they're going to take a look at your GitHub and see the presence, the things that you've done, and how this bar here looks down below. Does that answer your question, Connor?
Yeah. Is it a choice, or are we going to have to make an individual like repo for each one? Because if I were to prefer it, I would prefer it in one massive one because I already have like 70 or a lot of repos and I don't want it like polluting, you know what I'm saying? Like I don't want to have like 300 plus repos.
Yeah, no, that makes sense. It's definitely a choice. We're just making a recommendation here. Aiden?
Yeah, I was just gonna ask, so in the case, if a repository's contents need to be private, let's say like a repository contains like an API key in there somewhere, which it shouldn't, but if it did, how would you recommend building a GitHub presence if the majority of our projects are private or need to be private for some sort of reason?
Okay. So we should have enough time to entertain these questions, so I'll get into that. When it comes to private projects, are these projects, I guess my following question would be, are these projects deployable? Can you get these projects on some sort of platform such as like GitHub Pages, Jupyter Notebooks, or maybe some sort of EC2 instance on AWS?
Okay. That makes sense. So essentially, so if you have a private repository, if you're able to deploy it in some facet, then it suffices for having like missing gaps in your GitHub profile.
Yes, essentially, right? Your projects are always going to speak louder. And if they don't see a bunch of repositories inside of your GitHub profile, as long as that bar at the bottom shows that you're making constant commits and you have some pretty good achievements, then you'll look good. That's your question?
Thank you. That makes sense, yeah.
All right.
Wait, don't private commits still show up on that chart?
Yes, they do.
Main branch is what is tracked for public or private.
All right. Fantastic. So now that we talked a little bit about forking, it doesn't seem like there are any other questions regarding forking. So let's go into cloning, right? So now I currently have this information. I'm within a Git repository. Probably not going to work out here. I'm not going to do it nested within. Instead, what I'm going to do is I'm going to change directory one back. I am now on my desktop, and now I'm ready to clone. Currently, this information only lives within GitHub. How do I get this project into my machine? Well, I can't just git pull, because git pull would have to happen from an original remote origin source, right? Instead, I have to use a separate command called git clone. So here again, we have our HTTPS that we can copy. So I'm going to copy that over. I'm going to go to my terminal. And just to make sure that this isn't getting confused, I'm going to actually open up a terminal instance here. All right. Currently in my terminal instance, I'm within my desktop. And I'm going to run git clone and paste that HTTPS link there. So now when I clone it, we can see, hey, I'm cloning something. I'm grabbing the remote branch. All right, my remote object has been made. And this right here is going to be the name of the directory that gets pasted on your desktop. I know it's not sharing on my screen. I have 3 desktops and they all fall inside of my main one. So if I run change directory into algo 99 bottles, is going to actually change the directory there. Now, if I just keep this Git oriented, which I will for this lecture, I'm going to go ahead and put this back over here. All right, if I just keep this Git oriented, I now have this cloned. Well, if I do Git status, it's going to show me that I'm on my branch tree. Everything is clean. If I do Git branch, it's going to only show me the main branch, which is what I expected, right? When I forked it, I only forked the main branch. I didn't fork anything else. So it only shows me the main branch. All right. Well, what else can I do here? I can still make my own branches. I can also do something like check out all of the existing logs. So here's the log. The last one is for me when I updated the doc to have that no existing or no considerations at this time, right? Before that, we can see that there were some by Kate Fisher. Before that, we can see there was some by Dakota Cannon. And then before that, we can see that there was one by me yet again, right? So I still have access to everything that happened even before I cloned the branch because it's all being tracked by GitHub and Git, right? So when I did this Git clone, I didn't just pull down all the code. I also pulled down all of the log history that has ever been made to this one repository. And everything just works from there. If I run code, period, it's going to open up Visual Studio Code. And you'll see that Visual Studio Code pretty much has everything I need in order for this to work correctly, right? So here I have the bottles, foo.py, which I'm not sure what that's for. And I have this README. And that is how you clone a repo down from GitHub. Does anyone have any questions regarding cloning and forking?
I have a question. I thought earlier that I think it was Adam or might have been when talking about it, saying that you probably want to clone in the class over fork because if the fork gets deleted, you could lose some data. Or there was a comment made earlier, and I just want to go back to that for clarification.
Yeah, awesome. So I guess the question would be, why would I want to clone over forking? Is that correct, Lynn?
Possibly. Someone made a comment earlier about cloning versus forking and how cloning should be the preference in the class. And I just want to make sure that I heard that, and I'm just.
Yeah, no, that's definitely right. So here's the reasoning behind that, right? So cloning is definitely going to be the preference. And now we've covered forking, how we can fork, we can sync our fork, and that works great. And it does what I want it to do. But at the same time, it keeps this track to something going on to code platoon assignments, which I don't necessarily want. Not only that, but it limited me only to a few number of branches, and it kind of makes the process have a little bit more elbow grease than what it needs to. So let's go over how we can actually clone this algo 99 bottles straight from Code Platoon assignments. So currently I'm in Code Platoon assignments. I'm going to change directory 1 back and delete this algo 99 bottles. All right, so algo 99 bottles is now gone. I have it in Code Platoon assignments, and I want to clone this repository straight from Code Platoon assignments. So I'm going to go ahead and go to algo 99 bottles, take that HTTPS as normal. I'm going to run git clone. All right, so now git clone worked. If I change directory into algo 99 bottles, we can see that everything is there still. If I run git log, I still have the same number of logs, so nothing has really changed up to this point, right? The key difference is that if I run git remote -v to figure out what my remote branch is, well, now it's attached to Code Platoon assignments. Whereas when I forked it and then cloned it, my remote was attached to Fravala08. Okay, well, now how do I get this up to GitHub? Well, let's go through that process one more time. I'm going to go back to Fravala08, go to my repositories, make a new repo. This one's going to be 2. And actually, I'm going to do algo bottles 2. I'm going to make myself the owner. It's still going to be public. I'm not going to add a README. Everything works perfectly fine. And it's almost the same exact process, right? So everything works great. But now when I get to this process, or when I get to this point down here, there's a pretty key difference. So if I run git branch, it's not going to show me here, but I actually have all of the branches that came from GitHub. And I could pull all the branches. I believe if I utilize git fetch, it will pull all the branches. So now if I do git branch, oh, didn't work. Let me give that one more shot. Here we get puzzle. All right, there you go. So now, since I utilized fetch, it was able to grab my branch. And all I have to, oh my God, it's still not there. Let's see. So it didn't show up, but it was able to clone down the context. If I look, I did get checkout solution, and it does show me the solution exists, and I was able to switch it over, even though it wasn't showing it in the logs. So that's just a weird behavior. I have to look at the command as far as how to pull that down correctly. But all of the branches were effectively cloned, and I have access to all of them.
Maybe if you do a -r flag, maybe
A -r for get fetch.
git branch -r. It should.
Yep, there it is. Thank you, I appreciate it. All right, so it looks like the -r flag is showing me all of my different branches. That is good, and I will make sure it gets added here on the notes before I forget. All right. So now that we have this information, and I know that if I run git remote -v, it's still showing me Code Platoon assignments. Well, all I need to do is switch out the remote branch for the one that's currently in my repo. So I could say git remote rm origin. And now if I run git remote -v, we see that now it's empty. So the first time I pass the argument, get remote -v, it tells me where origin is located. I then remove the current origin. When I check get remote -v, nothing comes up because it no longer has an origin. So now I could add one here. I'm going to go ahead and copy my HTTPS I'm gonna say git remote add origin and paste that in there. And one more time, if I run git remote -v, now we can see that my remote branch has changed from Code Platoon assignments to Fravala 08. All right. Now for the final step, there's nothing to commit, so I shouldn't have to do any commits. I can just say git push origin main. And now when I push that up, if I refresh, we can see main. If I click on all branches, we're still only going to see main. So now what happens if I do git push, just in general? It's going to ask me to set an upstream branch. Okay, not going to get into that portion just yet. So let's go into git push origin solution. And now when I push that branch and I refresh this, we can see that I have both my main and solution branches. All right. And that is it for cloning. Cloning and forking are pretty simple. Cloning is a little bit more of a hassle as far as getting it cloned down. But if I take a look now, oh, and I went to the wrong repository or the wrong place. I'm gonna go back to my repos. And I open this up. Well, Algo 99 bottles doesn't have any sort of relationship to Code Platoon assignments. It's truly mine as of right now. I made a complete copy that's independent. Well, in my other example of Algo 99 bottles, that one still holds a link because it was forked. It continues to hold a link to Code Platoon assignments. All right, so there's the key difference between forking and cloning. The process is a little different as well, but the end state is the same. Are there any questions regarding forking and cloning at this point?
Yeah, I'm still. Does it matter which one we use? We can do either one. Is that true, or is our preference, or how we should do things?
Yeah, that's a great question. So to answer the first question, you can utilize both. To answer your second question, as far as a preference, we recommend that you utilize cloning over forking.
Thank you.
Of course.
So with these assignments, there's no evaluation of our code.
Yeah, when it comes to your actual assignments, and I'm gonna wait for that question here until after we're done with lecture questions. Then I'll pause and I'll answer any general questions. All right, it looks like there are no questions regarding the lecture. Let me double check to ensure that everything from today has been covered. All right, we are good. I'm gonna go ahead and stop the lecture recording.